Hello everybody, welcome to another stream. I did not realize my camera was in the wrong place. Oh. Okay, that was weird. Anyways. Welcome. Magic. Right. So, last stream. Let me just sort that. Jobs again. So, last stream we were getting the GPU rendering code for these new sort of materials all in place, and we kind of encountered a compiler bug. So off stream I fixed it up and now it works. So we've made these rendering changes on the GPU where we can hit with the ray against the UV. Sorry, hit the ray against the sphere or the ellipsoid and get the UV, and then sample the texture. But we're not calculating a MIP level yet. We are sampling the texture though. So we can run that and see how terrible it looks right now. So we're using a very poorly generated texture, and it's very low resolution because it is only loading the lowest level of detail. So doing 128 pixels by 128 pixels, that's what it's good for. And it's kind of this yellow and green texture. I don't know why those ones sort of popped in, that was weird. But yeah, this is what it looks like up close. It looks horrible and ugly. There's a bit of a seam as well. So, there's a seam we've got to fix. But essentially the texture that we're procedurally generating is this one here. It looks horrible, but yes. It's just some random noise, basically. It's randomly generated it. But I think after we get this material system done, like all the rendering changes, I think we'll spend some time and generate some proper good materials. I got some plans down here for like wood and maybe like a volcanic ground looking one. So I think we try some of these out and make those. It'll be a lot better to look at basically. So let's bring our scene down to a very simple scene. I think the camera's in game. Let's try that. So we should be looking directly at the single sphere now, I think. Yeah, good. So this is all we've got at the moment. And we're going to work on the texture streaming code today. So right now, this is loaded into the lowest level of detail. And see, it's all blurry and horrible. So right now we look at we've got a bunch of a repeat of these sort of materials. So each says material albedo, right? It keeps repeating it. So there's albedo, emissive strength, metal roughness, heights, and normal. Then it repeats again. And the reason why it repeats is because that's the next level of detail down. So it starts from the lowest level of detail, this one. So as you can tell, the texture's stored in here, and it's only 128 squared. So when we get closer, we want it to go into the next level of detail, which is this one, which is 256 squared, and so on, right? The closer we get, the higher the detail should be streamed in. So yeah, these are basically just texture 2D arrays. So notice there's array layers, there's 1024 for this lowest resolution. So it can store up to like 1,000 materials. So, and obviously it has the full MIP chain going down to 1 by 1 pixel. So it can deal with spheres of all sorts of sizes, but the one which is closest is the one which is requesting the highest detail, right? And there's only so many of the highest resolutions you can store. You'll notice as we increase the LEDs, this is the 512 squared texture, there's only 64 layers. So you can only have 64 with 512 resolution. And so as we go up again, this is 1000, there's only 16 1000 by 1000 textures, and so on. So what we're working on today is making that code which transitions, which goes, hey, this ellipsoid that we're trying to render here is bigger than 100 pixels, so I need the higher resolution texture for it to stream that into the high resolution texture cache slot, if you will, the texture cache 2D array. So what we need to do is we need to figure out how do we get the level of how do we approximate which texture that we need. So the problem is in the CPU side code, we don't go over every ellipsoid that we ever want to render. We have models and we have model instances. The model instances reference the models, and the models obviously hold all of the ellipsoids. But we give the GPU a list of instances and a list of models, and the models are kind of persistent until they need to be unloaded, whereas the model instances come in every single frame. So we need a way for the GPU, so we're going to keep this GPU driven, we need a way, so we're going to inject somewhere into this sort of pipeline here, into this frame on the GPU. We're going to insert probably after, maybe when you have prepared the rendering, might be somewhere around here. So emit ellipsoids, this one here. So after we emit the ellipsoids, we might go over all of the ellipsoids that we've emitted to render. And then we're going to go over all of the ellipsoids, get their height in screen by in pixels, and use that as a metric to be like, they want a texture which is, has this much resolution, and then it will load all those materials into GPU memory for that LOD, right? So that's what we're going to start off on today, is writing that writing the code which will detect which LOD that we want on GPU, and then we're going to send that back to CPU. So a few frames later, it will have it all loaded and ready. So that'll be pretty cool. So I made a restriction in the material system where I wanted to have, there's 1,000, well, that actually, yeah, there's only a limit for 1,000. There's a hard limit. So there's a limit for 1,000 texture. What is it? Yeah, there's a limit for 1,000 materials that can be loaded at once. There you go, 1,000 unique materials loaded at once. And the reason why I had this restriction is because, well, one, it's kind of good to have some restrictions in places, right? But it means that there's enough room on today's hardware to have a compute shader which runs, and you can run over 1,000 ellipsoids in a group, and you're going to go over all those 1,000, and we can have 1,000 max LODs for each material, and essentially atomic max into this buffer, into this sort of buffer which is in group shared memory or LDS memory, right? And this means that we can then, when we've gone over all of the ellipsoids, we can then we can atomic max all of these back out into a sort of a feedback buffer, which would be quite interesting. So by having that limit of 1,000 means we're using, I think it's 4K. It'll be 4K of LDS memory, which compute units have these days to use. So it should be quite performant to be able to on the fly scan over all the ellipsoids and basically work out the LOD that they want for a future frame to then be loaded in for a future frame to render. So we might be off by a few frames, or we might have to be a little bit I think the result, the way we're going to check which the way we're going to work out which LOD the material needs is going to be it's not perfect. So it's going to have a margin of error where, it's going to have a margin of error such that it's going to try and load them in a little bit earlier. So it should be good. Cool. So let's get started on that. What we're going to be doing is going into the shaders, I guess. I'm just writing that shader out. So we've got a material section now, isn't it? I think so. Well, why would we have a material section? Oh, I do. For the downsamplers. Right. Okay. Right, so this one's going to be... Well, it could go near the emit ellipsoids. Yeah. Model instances emit ellipsoids, so that emits the... Yeah, so after emit ellipsoids, we're going to be doing ellipsoid material LOD feedback. So guess what we'll call it. LOD feedback. Beautiful. So I think we can do 1,000 at a time. Maybe 256 is better. We'll see about that. We can we can change the number, right? So we're looking over these render ellipsoids. That will give us the material index, but I don't know. Maybe I want a separate buffer where I can, because I need the bound. What I need is the height. Yeah, what I need is the height of these ellipsoids. Maybe I could put out a new buffer in here. Maybe we can make a new buffer called... Let's just write the code out, and then we'll figure out the inputs. Because we have the bounds, there's no point in writing out the full bounds into another buffer. Yeah, I think we want to write out just specific bits of data that we need. So we're going to want to have like an ellipsoid material LOD feedback ODS. This is too long. All right. So this would just be some global. So dispatch group. So it's globally shared between all of the threads in the thread group. So all right. So I'm thinking about storing all of the material LODs in here. Now, we could make it floating point, but then you can't. We can do atomic max with floating point. Well, yeah, you got to do it as an integer though. But yeah, it could be as floating point. So this would be LODs. because it's positive, we can do the yeah. We can just reinterpret cast it to an int and do a max and it would be fine. So graphics, materials, capacity. That's probably got to move to some kind of shared place because I think it's in a, yeah, it's in the internal right now. Let's fish that out. So graphics, internal, shared. Let's chuck it up here somewhere. Unless I've got materials nearby. Well, I thought I started adding a material section. Oh well. Well, I think, oh, here we go. Alright, go on here. Plop it in there. There you go. So, right. So I'm thinking that we go over every single sphere. So all we need is, let's just make some variables and we'll figure out how we fill those in. But I think we'll just, well, ellipsoid height in screen space. So we'll fill that in somehow. And we want the, also its material index 2. Again, we'll fill that in somehow. So it's going to, so it's going to do some kind of like, right, so let's, so you take this ellipsoid here, right, you get its height in screen pixels. Now, that height in screen pixels, imagine if you put the texture that it's got just flat on it, right? That should be a good enough metric to use. So we take that height in pixels and we get the log 2 of that, I think. So if you have 128, log 2 of that would be 7, is that right? I think so. Does it? Yeah, 7, good. So you do log 2 on the height. So you can work out the LOD by taking, so this could probably be an integer form. Then you can say LOD equals log 2 of ellipsoid height. Obviously cast it into a float. Now, so you're going to get some sort of floating point LOD, which is probably what you want to be sent back. Right, and then, yeah, I think that'd be good. So, and then all we're doing is basically saying, right, in that LDS memory, well, actually, hang on a minute. We need to do a control barrier dispatch group. So we need to initialize the memory. The LDS memory though. Oh crap, do you want to wake them all up? I don't know what's better. So dispatch local index.x equal 0. So that'd be 0.0 in float representation as well. So yeah, we'll see if there's better ways to initialize that. We'll have a play around. So this will come from somewhere, take the LOD, and then we simply just say okay. Wait a minute, you're meant to be going over... Yeah. So then you'll say atomic max U32. That's right. G material LOD feedback dot materials material LODs now the material index we get goes into here, and then we atomic max a sort of bit casted version of LOD. And this trick only works, so the reason why I have to do this trick is because we don't have atomic max operations for floats on GPUs. It's an extension, it's not really well supported. So if your value is, if it's a positive value and it's not infinite or whatever, right? It's a finite positive value. The min and max operations work if you were just to bit cast it into an integer. So that's handy for those sorts of cases, like this one. So the next issue is that we need to then write it out to a main buffer when it's done. Now I'm a bit concerned about the way this is taking shape right now, because we need to, first of all, we're spinning up like a bunch of different waves to initialize that to 0, then we're waiting, then or waiting until they're all done basically. I don't know how that would behave. Then we're only doing like one operation basically per thread, right? And then we're presumably going to want to then write out to main memory the result somewhere. So presumably you would need some kind of barrier again, and then you'll need to do something like feedback, what do you call it, output, I guess. I don't know, maybe we could put it in the readback buffer. That can work. So put in the readback buffer, we'll go. So I think there's a thing for it. There's like a GPU shader, right? Readback. Readback store float 32. Yeah. So you'll load the LOD back out. So you'll be like LOD equal G material LDS feedback material lods, whatever the dispatch index for this thread is. And then you'll say if you got to do a bits to float. There we go. Jobs are good. Yeah. So turn that back into a floating point. Just reinterpret cast and put it back into this variable here. And then we'll put it into some, I was thinking about doing a GPU readback store. So this is just, there's a global readback buffer we can just put stuff into. And we'll probably get a byte index which comes from the readback destination, readback offset. Okay. Plus material. So this is the new material index, mind you. material index multiplied by size of, because it's a byte index, because there's a byte buffer, but it's like the HLSL byte buffer basically, it's just inspired by that. So you run it back to that and the value is this. So we'll be able to read that back. We just have to make sure that we CPU side say, hey, we want to be reading back this much data, and then we give the offset into the readback buffer into this shader, and then it will just write it all out there, which would be pretty nice. So then you would just, but you only really want to do this providing the fact that LOD is not 0. But you could, no, you could get it to write back the 0 ones as well, so you don't have to 0 initialize that. Yeah, maybe. Well, sorry, the issue is you've got to, you'll have to atomic max it into this buffer. Yeah, you will, won't you? That's alright. Okay, so maybe putting it directly into the readback buffer is probably not ideal. So we might have an intermediate buffer, then we'll put it out to a readback buffer. Oh, I don't know. Right, we'll leave that there for a sec. So all we need to do is say, do an atomic max E32, this time into like a call an output material, output index material index, and then LOD. Oh, and again, you can't use a float, so you've got to use the integer form of it. Okay. Yes, I think we might have another one which will basically just, yeah, we'll probably have a different readback command which will read back from the this output buffer, whatever that's called. It'll be called something like material LODs, and then we'll read back that whole buffer, and that's what we'll do. Okay, so yeah, I still don't like the way this shader looks. So my problem with it is I think we're not, or we can definitely try it out though, and just see how well it performs when we sort of scale up the scene. But I think it's not going to be great because it is, I think it would be better off, like, because this is probably going to cost something up here at the top, and this is probably going to cost something at the bottom. So I think it's better if we probably offset some of that cost by doing more of this here in the middle, by maybe processing more elements or something. But yeah, I think we can try that later on. Let's just get the streaming in working and then just see what the performance is like and have a bit of play with that. So where is this coming from is the next thing we have to suss. So I'm thinking we could probably cram it into a single buffer, maybe. Like this needs to at most be 4,000. Sorry, 2,000 and something. So that's only maybe 12 or 13 bits that we need. Yeah, let's say 13 bits. And then this only needs to be up to 1,000, which is just another 10 bits. So really all we need is these are kind of, what we'll do is two 16-bit integers, which means that what we'll do is a single 32-bit int, because you can only use 32-bit ints in, well, that's the restriction we've put on ourselves, right, at the moment, is 4-byte ints and stuff. So why don't we cram into another buffer when we emit our render ellipsoids? We'll need to pack it, so we've got the bounds here. So I'm thinking let's just go okay. We'll get the height. Well, the height and screen space is right there. I've already done it. So we're gonna we're going to take the so on the height and then the material just packed in, right? So I reckon if we max that, or we take the minimum between this and there's like a, well, I think it's only on the CPU, isn't it? Yeah, there's like an LOD dim max thing here, right? I reckon we can take these, move them to the shared shader. Because I want this number here, the LOD dim max. That's what I want. So we take the minimum between that and this one here. And then that'll be our height. So we'll say that we'll give this one 16. bits. Want to convert that to an int as well, be pretty wise before we do that AND operation on it. Then we also want to take the material index and cram that. So we get the material index right here, don't we? So maybe we so there's a material index, and then we want to sort of pack out into, we'll call this, so it's writing it out into the beat, like we'll call it ellipsoid feedback input. It's a bit long. Yeah, so ellipsoid material LODs. Well, if they're LODs, we'll log to it, right? But we're not going to do that. Yes, it's not ellipsoid materials, but it's like not really LOD as well. It's like a material and height, I guess. Let's just say it as it is. So that'll go out into the destination index. It's just another parallel buffer, and we're going to cram out some kind of material and height into a single int. So let's make that thing now. So if we take that material index, and then we don't really need to AND it because it's going to be under 1,000 anyway. Well, let's do it just in case. Just show what it does. So these will then be shifted left by something. So we can say 0 for this one. Well, it's not really going to be aligned, but okay. And then shifted left by, wait a minute, I got to bracket more of the things. Well, I could use my encoder system here and just whack out a sort of a material and height thing. Maybe. I don't know. So that'll be 16, okay? So now we're just whacking that out to there. Good, good, good. Then all we're going to do is read from it here. So we get a material and height. And that'll be the SV dispatch index.x. Then all we're going to do is read that out. So be material and height and 0x FFF. I guess we'll it'll be alright. Now this other one is shifted by 16. Cool. And there we go. So yeah, that'll work. So now all we're going to do is make this. We're going to make this buffer. We're also going to make this structure. Right, so what goes through here is probably just that U32, which would be that material and heights for the ellipsoids. And then another one is another U32, but technically it's a float, and we write to it, and we just called it output. But I guess we can call this material LODs, right? So technically it's floating point. Actually, F32. And we atomic max to it. So yeah, we'll call it material LODs. Okay, good. Right, so let's go ahead and make that buffer. Gotta copy that one and put it into this emit ellipsoids as well. It's read write here. Yep. And I'm going to go ahead and go into the graphics code now and write this all out. Ellipsoid, material and heights, and again, ellipsoid, material and heights. Now we're going to go ahead and get all that ready here. And again, we do that in the initialization code. I misspelled it, didn't I? Is that right? Neat. Yeah, so this one has the same number of instances. It's obviously just U32 instead. Right. So when we emit it, we want it as read write here. Then we want another shader which goes afterwards, and this is going to go over all of the ellipsoids. You see, I wonder if I could do this as part of the emitting process. Maybe, that'd be interesting, right? Because it's already... Wait, let me delete these two debug files. Give me a sec. Oh. I was debugging my shader compiler. I was getting some weird bugs that those files were just there. Right. So when we emit these ellipsoids, currently we have one thread per model. But it's not really the best. Because then it, and then I guess, sorry, one thread group per model, and then it has 32 group, 32 threads within a group, but processes 32 ellipsoids at a time. Now, that's okay, but you end up running this same code for just basically one thread. Sorry, one thread group ends up running the same code, and it could just, and it's kind of scalar. It's it's the same information on every single thread, and you're not gaining anything from it. So essentially it's running in single threaded mode in a sense, because it's only using the group index, and you're not gaining anything from 32 threads running the same code on the same data. So I think we probably just get this to output all of the models that you want to, or the model instances that pass the occlusion test, and then add to another buffer. And then those ones, you could do this one thread group thing across 32 ellipsoids. Yeah. And then you could have the LDS memory here to figure out all of the LODs and that without having to write those out to main memory. Yeah. Yeah, I think we can do it without another pass. That would be pretty ideal, actually. Then we won't have to do another... We won't need this other buffer, which would be quite alright, actually. So why don't we do that? No, we still need another buffer, though. But not this buffer. So let's get that other buffer in. Right, so this new buffer will be called the material LODs. Yeah, but how are we going to write them out afterwards? I think we got ideas. Yeah, it's possible. Alright, let's get rid of that. So actually, float 32. Nice. So graphics internal. I'm thinking of just having this called material LODs buffer ID. And then graphics. Okay, we'll do it again. So material LODs buffer ID. And we'll find wherever this is and put that there. Well, not really. Right, where it's initialized basically. Now this one we just want for as many as there are materials. So at most we swap to 1,000, and we have that restriction such that we can do this calculation on GPU and probably have this sort of like, you know, we can pre-allocate all the materials at a certain resolution as well, stuff like that. Okay, a float 32, beautiful. Nice. So that should be there. Cool, so let's get back to the GPU and move this code around. This would be really exciting. So, yeah. Yeah, we won't split these shaders up for now. Let's just get this, what we came to get working. So we still have this LDS, no, we're gonna have to split the shaders up. Okay, and do it now, okay. So we would like to So for all the model instances, we should have model instances col or something like this. Or you just do quick culling basically. Well, I don't know if it is better. No, we don't need to split it up yet. I just realized we can do a bit of maths and it should be good enough for now. We'll try and optimize it later if need be. So the trick we need to do, say we want to support 1,000 of these. We want to process in 32s. So 32 times 32 is 1,000, which is great. So we can say, so you get times 32 plus model instance index so you can have 32 of them in a single thread group. So you times by 32 plus your sort of like local index divided by 32. Something like, is that right? So model instance base index, let's just make it a little bit more readable, local index, which is this number, and then it's the base plus the local. So you have 32 per thread group, and then yeah, good. That makes sense. Okay, so anywhere else we use that dispatch group index? No, we don't. Cool. So we use the local index though. So dispatch. Let's look out for the word dispatch and see what we can do. So, right, local index. I guess we'll just say divide. Interesting. Oh no. Mod 32 in this case. Good. Yeah, so we're still going to keep 32 threads. Processing 32 ellipsoids at a time. Again, it's still not the most ideal. So I just put a big old fat to do here. Or maybe we just save the jank and just do it properly. Right, save the jank and do it properly. Sub process. Maybe 256 is a good number. It'll be this code. where's the... Yeah, this sort of code is what I want. So go over all the model instances. This time it'd be one thread per model instance, so it'd be just far better. When we have tons of model instances, this will just work out better. Right, local index we don't care about, I don't think. So we get the number of... Okay. So we'll copy to some global, this will be the render. Model instances count. So this little trick here is so you don't just do one atomic add. Yeah, this. So rather than just doing this atomic add per thread, per 256. Sorry, for each 256 threads, and then it's really every thread in this compute shader. Instead of doing it in a for every thread of the compute shader, you're doing it for every one thread in 256. So we're doing an active sum. Oh, this is a wave though. Well, okay, this is doing it one every 32 threads. It's still better. It could improve, but there you go. Yeah. This will be fine. Let's just do this for now. And then you write it out. So it'd be BC render model instances DST index. Now, the thing is about this structure. Yeah, let's just copy the index. It'd be too many bytes to copy the whole structure, I think. I don't know. So it'll just be an indirection table, basically. Okay. So that'll be alright. So it's got to zero that memory as well. So that'll be model. Yep. Let's just clear that a bit. Right, so we'll clear up the CPU side code in just a second. Let's correct the GPU side code. So we're adding this sort of like LOD feedback thing, which would be interesting. This emits the ellipsoid. So to get the... It will be BC render model instances. SV group. Well, are we still doing... Yeah, I still think we might be doing that. Indirection, maybe. Yeah, you still have to calculate these base and local indices. Hang on a minute, I forgot my if guard. if the model instance index is greater than or equal to the model instances count, then we will return. Nice. So we've got to... So you got to do that same sort of thing here as well, I think. Yeah. So we're still going to have 4 of them. Wait, no, we don't want to do that anymore. We need to launch 32. Great. Perfect. Yes, that goes back, going back to 32 now where it processes. $32 at a time. No, I think we'll go back to doing this because I want to make this larger. So it can process 4 model instances, sorry, 32 model instances at once. Maybe we'll do a little bit less. Let's do 256. Might be better. So that is 4 times less, isn't it? So it'd be 8. I think, is that right? Yeah. So it's 8 per group. And right, then you do the redirection. Okay. Great, so that will mean you can step in 32s at a time. And now the wonderful thing about this is that we can take this code here from this feedback thing we threw together. Oh, they've got to be 0 initialized though, isn't it? Yeah, I wonder if we can say... Yeah, I wonder if you want to do the first wave and do it, iterate 8 times. That might be better. Let's try that. So we want to say if local index.x is less than 32. Then do a quick little for loop. Over 1,000 materials. And store zero into the LDS memory because you've got to initialize that. And then wait for this to be done before continuing. Okay. It's pretty reasonable. And then the other part to this code was this here, which works at the LOD and does the atomic max. So we can now move into this for loop here. So you step in, this loop steps in 32s, and there's 32 threads running at a time through here, unless obviously it goes off the end of the buffer, off the end of the number of ellipsoids. Then basically we somewhere about here, when we've accepted the ellipsoid, we're also going to write out to this buffer called material and heights, but we realized we could probably just do the LOD feedback stuff within this same shader, which would be pretty cool. So we've got the height. So we can use the LOD by getting it to take a min. We don't really need the min, to be honest, because we're not cramming it out to anything. That should be alright. So log2 of the height and screen space. And then we literally just atomic max that with the LDS memory with the material index, bitcast it into an integer, so then that'll work. So this can go, that was trying to do. So I'll put it into this LDS memory here, which has been zeroed, and then you should be able to process. So there's 8 different models, 8 different model instances with, and then going over possibly up to 32 different, or 32 or more ellipsoids actually, depending on how many are in the model. And then it's going to go over and atomic max the largest LOD. You know, I might go back to 1,000, processing 1,000. Yeah, processing the, where is it? Yeah, it finds the largest level of detail for this material that we've found amongst all of these ellipsoids that we've processed. And then at the end of processing all of those ellipsoids and things, we need another barrier. So it's this code here, basically. We need another barrier. And then all of the threads wake up again. You know, yeah, we'll do 1,000 again. So we put it to 1,000. It just works a bit better. So it's 32. So there's 32 model instances within the same thread group. Okay. Then we make our material index be the local index, which would be from 0 to 1,023 inclusively. We read from, we atomic max into a materials LOD buffer, and we atomic max out the LOD here. Now, my concern is we only really want to do this providing the fact that LOD is non-zero, really. That doesn't matter, just do it. Otherwise we've got 0 the buffer. No, we'll 0 the buffer. Yeah, we'll 0 it. So if you have an LOD, then do the atomic max. Okay, let's try that out. Cool, so we can get rid of that temporary shader we tried to make, but it's better just to cram it into one shader, I think. And right, what else do we need to do? Yeah, we need to make sure we 0 the buffer, and we now need to call these two separate. I made this separate shader for this one. Oh, it might want the model in the view from model. Does it want that? Yeah, we need to get the view from model out. And that near clip plane distance, do we need that in the other one? The thing we did is just copy these. We want them here. I don't have the model instance extracted out. Let's get that. Right. So that's in the emit ellipsoid shader again. Good. So we made a separate pass now for the model instances, so they'll process one thread per model instance rather than the same code running for a whole thread group. Cool, so we need to make a new buffer called the render model instances in this constants structure 2. So we need these two and write the model instances in the model. Wait, do we need the model? What is the model used for? Nothing. That's only used to get the ellipsoids out. Got it. Great, so that's one less buffer there to pack in. So, and bit of data to pull out. We don't need the ellipsoids or the bounds or the render ellipsoids, but we'll have our own render model instances. Which is just an array of indices into this buffer here. Then we need that same one here, but as read only. So let's get that set up CPU side and then give that a go. Hey there, Pete Riggs. Evening. How you doing? Yeah, I'm not doing bad, thank you. Got a bit of a sore throat, but yeah, I'm all right. Doing all right. So is this for streaming textures in as you need them? Like as you move around a large map? Yeah, so yeah, effectively, can I run this? Yeah, so right now we've got this guy. Very terrible procedural texture I made. We're going to be doing, after we got the streaming in, we're going to make some nice looking ones. This is just a bit of noise. If I just boost this up. So it's just a bit of noise and then I just colored it. It looks horrible, but it's in that sort of 1000 squared texture 2D array. It's got 1000 slots in it. So this is the lowest resolution one we've got at the moment. And if we go to the next level up here, 256 squared, right, it's currently black. Then it's got 256 slots in it. And as the detail increases, the less slots we have available. So right now, when we get close to this thing, it's blurry. So we need to somehow know what quality this material needs to be at. So we're going to load all of them in by default to the lowest quality, but when they get rendered on screen, we're trying to feed back from the GPU what is the level of detail that they need. So if you take a look at, we're taking the height in pixels of the ellipsoid, we're taking the log2 of that, so just whatever it is, what's that most significant bit kind of thing, but you know what log2 is, right? It's what it is in binary, basically, right? Wait, not log2, not binary. Yeah, so like if it's 128, it'd be 7. If it's 256, it'll be 8. That sort of thing. Now, we don't know how big this ellipsoid is on the CPU side, on the screen. We only know on the GPU. And we know how big the model instance is. So if there's one model instance, which was one ellipsoid, we could know that. Or we could take a best guess. No, we could work that out. But we have model instances which reference a model, and those models are loaded into GPU memory only, or they're streamed into there when they're needed, right? and so the model instances reference the models, and the models ellipsoids only live on GPU. So what we're doing is we're writing some code which will basically take that height in pixels for the ellipsoids when we process them to say, hey, we want to try and render this ellipsoid, and somehow write that LOD back to the CPU, and then the CPU can be like, right, we've got this new level of detail that we need for this material. Move the material texture from this smaller texture to the bigger one, and then it will get it all ready for a frame or two later, basically. So yeah, that's what we're working on right now, is that code to sort of feed back those material LODs. There's only 1,000 loaded materials at once, because 1,000 should be enough, right? Random model instances. Okay, so let's go to graphics. We need to make a new buffer called render model instances. Why isn't that pluralized? That 1,000 is based on the max texture layers, or no? Yes, actually the max one these days is actually about 2048. But yeah, it was when I was looking at it. Yeah, 1,000 is still slightly better, but yeah, most of them these days is about 2048. But it was mainly just because there's two things, right? We could probably have we could probably have 1,000 low resolution ones loaded quite easily. And as you up that number, the harder it is. But also this sort of feedback thing, feeding it back on the GPU. I think the main thing that had that 1,000 restriction is the LDS memory. If we have 1,000 times 4, right, 4 bytes being size of int, that is 4,000 KB. And basically you've got that for free in, like, if you use 4 KB on this AMD GPU that I've got, which is not the best one, it's sort of RDNA 3 mid-tier card, something like that, you can have that much LDS memory being allocated per thread group, and it will mean that you still have up to 32 thread groups which can run on the same compute unit. It doesn't stop. Like, if a compute unit reaches an instruction which does a memory read or write, and it's not in cache and has to wait, it will switch out to another compute shader and runs that for a bit. So these days, from what I understand, when I read the documentation, you have 32 of them. It used to be 10, but now you have 32. So the more LDS memory that you use, the less compute shaders it can switch out to hide latency. So yeah, using 4 KB is still fine. From when I read the docs, that's what I understood from it. So I think if we use anything more than that, it will mean that the compute shader will possibly run slower, because it can hide the latency of memory less. But maybe not, depends. Yeah, just have to test it out, I think. So yeah, that was the other restriction. So model instances, I guess I can move that up to here. I see interested. It's a nightmare managing all the different GPU specs. Guess that's why many games compile shaders when they first run the game based on what GPU you have. Yeah, I don't. Yeah, so the reason why they compile the shaders is because of pipelines. And yeah, that's because some GPUs want to insert special instructions to like write out a pixel in a pixel shader and or whatever, right? Do some extra stuff. And yeah, there is also lots of like shader permutations that engines do these days and have done for a while, I guess. So what they'll do, oh, for crying out loud, did I really? So yeah, so essentially, imagine if you had like templates, but for shaders, where you could say if you can basically if def out a bunch of code, and you have hyper specialized shaders for when different conditions are true. And on the CPU side, all you have to do is say, right, which of my 7 different flags, or what's the different combinations of these flags, and load the right shader for that. So you basically can have quite a combinatory explosion of shader permutations, and they just compile them. And there's ways of bringing that down, obviously, but yeah. But that's the main reason why the shader compile times take that long. And I think they have specialized shaders for different materials as well. So, and these are like material graph things that people have made. So they're probably quite complex. Right. So what I do is put in a read only for the render. Model instances buffer. And then copy paste this. Because I actually split up that shader into 2. So it's no longer render ellipsoids, it's render. Sorry, it's no longer emits ellipsoids, it's just there's one with emits, which emits the model instances only. Because there's a lot of waste going on. But it's a fast shader anyway, but I wanted to change how the emit ellipsoids worked. So it's better that it's split up. So we don't need the models. We want to read. Yeah, we want to read the instances, but read write. Right, and then we need the number of model instances to be put in here. Right, now that where's that available in? Is that in the payload? Gotcha. Beautiful. Occlusion culling. And probably use the globals. How many of these we launching? Oh, that's the thing, is it? Alright, it's made a local there, that's good. So how many of these we're launching? We're launching 32. I think it's 32 per thread group. So we've got to divide by the number in a thread group. And launch that, thank you. Yeah, oh, 256. Right. Cool. Okay. And then we've... Yes, the number of thread groups here, we've changed it. So we want... Oh, I've just made it confusing, but it's okay. So we've got 1,000 threads in a thread group because we want to make it easy for this material thing, but there's 32 model instances that get processed within a thread group. And then, you know, because 32 times 32 is 1,000. So that means the 32 threads within... Where's that local index gone? Oh, hang on a minute. The 32 threads within that. So there's 1,000 threads within a thread group. Obviously, in strides of 32, there will be another model instance. So within that sort of 32, they will process 32 at a time through of the ellipsoids for that model instance. So I haven't compiled this yet. So that means then when we take this model instance's number, it's kind of like, do you just divide it by, yes, you got 32 within a thread group. That's the way you look at it. So it's that divided by 32. Yeah. So I should really write a comment up here. Processes 32 model instances within a single thread group, right? Each model instance has 32 threads to process 32 ellipsoids in lockstep. Oh yeah. And obviously, you know, while this is going on, a thread group maintains the largest LED it found for each material and writes that out at the end, writes that out when the thread group terminates. Before the thread group terminates. Done. That's a good summary of what's going on here. So there's the write out there. Good, 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 good. Oh, I need to do that 0. Something I nearly forgot. So we need to make sure that we use 0. So we could probably put it here. So it would be something like a GPU buffer command buffer 0. Yep. Graphics material LEDs buffer. There you go. Wonderful. So I think that's it. We're obviously going to want to read back the results, but let's just make sure the thing still runs, and then we shall read back the results and see what they are CPU side. So we cannot find a render model instances count in the global structure. That is fair enough. It cannot because I haven't put that in yet. I thought I put that in there, not gonna lie. Oh, it's using the wrong constant. Sorry, the wrong constant structure. So it's using the, oh no. Hang on a minute. Oh, okay, I didn't pass that in there. Right, we're gonna need that for the, yeah, because we're processing 32 at a time in a thread group, we don't have exactly 32 render ellipse. Oh, right. No, that's got to come from, that's got to come from the new global. Because this would have atomic added into that. And then, so that's the new one. Cool. Screen bounds. Screen bounds depth. That's what it's called. It's got a depth in there as well. Do not forget it. Some music in my ears. Right, log 2. One does not simply log 2. One must log 2 F32, if you know what I mean. Cool, so now the GPU code is compiling, so CPU code must now compile. So apparently I've lost my constants, moving them into that other buffer. Sorry, other file words. They're in here. So why oh why? Oh why oh why? Oh, it's an ifdef HCC section. That is a problem. I thought. Right. I cannot have nice things, clearly, so we'll just put them all up here with all these constants. Future Henry will complain at past Henry and solve. We'll clean that up. For the good of the code base. Right, okay, I misspelled that. And here we go. Do we get a rendering ellipsoid? And the answer is yes, we do. Hey, Captain Chica, how you doing? Welcome. So, now, if we increase these ellipsoids like so, I guess we can check the performance on those shaders. You know, it never was slow, to be honest. Right, well, 4,000 model instances. It wasn't the slow part, honestly. There we go. Let's just pause it. That's the occlusion culling. It's after that. 0.02 milliseconds just to go over all those ellipsoids and emit them out. Yeah. So it's emitting 100,000 ellipsoids there. It's not a lot. And it's doing the atomic maxing into those buffers and figuring out the LODs. Great, so just got to read that back and we can see what we get. So we can now do ourselves a super lovely readback here. We want to I've got to do this readback queue thing. Let's figure this one out. Right, so add a new readback queue for material, LEDs. Plop that in there. What do we want to read back? So the reason why you got these readback keys is because you can technically put as much stuff as you want into. Yeah, I want to. Maybe it's a bit overcomplicated, but you need some kind of like. You need some way of identifying this thing you've told to read back, or that said you're gonna read back, basically. And the buffer itself is not good enough information. So the buffer we're reading back in question is the LEDs buffer. It's got 1,000 in there for the 1,000 materials that we have. The offset is 0. The size is the whole damn thing. Do I have a way to automate that? See. If not, we're going to add it in. Size 0 returned false. Well, alright. Let's make this code better. So all you do is you take this. And you're right. You do the hard work. Resource, buffer, size. Where does it say that it is a buffer as well? Yeah, we don't have that assertion there, do we? So we're just trying to say, right, size is equal to size, take offset. And then yeah, we also want to the problem is if someone passes in a massive offset, it'll, bigger than the size, it will put it into negative numbers, and then you will sort of say, oh, that'd be fine, because this will assert there, wouldn't it, for that one? That's good, good, good. Nice. Nice. So that's all I wanted. So just read back the whole thing. Awesome. Hey, been Captain Cheek, what have you been up to? Hope you're having a good week. So that'll read back. Now we've got to process that in the readback queue. So actually, sorry, technically you can read back anywhere, I think. There's no readback sections anymore in my code base. I used to have specific sections for reading back, but I think, yeah, queue read. So I just have to do this thingy. Playing around with comp time templates in C++. Oh, so like const expers, they call it. As the CPP people call it, you know, stud putter, stud unique putter, and the const expr, you know. Always love that when you watch like a C++ conference and you just hear people pronouncing all the shortened C++ isms. It's probably one of the best things from the talks. Stud vector. Wonderful. So yeah, a couple of frames later after you issue that, you get back these. And now you can update. So entry CPU data, I think it's called. And you can then cast that into a float. And we've got all of our LODs. So we can have a bit of a play. Let's just print out that LOD for the first material. And just see what it is. I say STD coat. Right, STD coat. Right, instead of C out. Right. Yeah, STD C out as well, yeah, coat. Oh, gotcha. Yeah. Not really, more like template to do that. It can be used to split the code out. It can be used for more general types. But also evaluate it at compile time. Right, guys, I believe we have perfection. Maybe. I don't know. Let's just... So there's the LED printout to the left in the terminal. And it takes the height and pixels of the ellipsoid on GPU and sends it back. Now, the question is... So LOD of 8 is 256 pixels tall. Now, I don't know if that is really 250. I got a 4K screen, and that just smells funny to me. So we're gonna... What can I do? I can do my... I can just take a screenshot with the power of F7 or F8 and go to screenshots and take a look here. Damn it, I thought I fixed this problem. It looks great in the thumbnail. Still criticism about it. Oh, it's the alpha channel? Wait, let me read that. Let me get that paint. Has it got alpha? I don't know how you use Creo. That's the thing I'm looking for. You telling me it's got alpha? Looks like it. Anyway, we'll solve that problem some other time. We're not interested. Oh, so apparently it is nearly 256 pixels. It says up there at the top left it's about 200 odd. What? So, that's alright. Maybe we can fix that problem now. So, that's the LOD coming back. If 8, so obviously one shift left of that is 256, or to the power of... So what is it? Or 2 to the power of 8. Gets you that. 256, right? So that's good. Hey there, Perry. How are you, sir? Welcome, welcome. Yeah, that's what happens when you use C++. Compile time just goes out the window. All the CPP stuff. All of the PP all over my code base. It's not very wise move. So yeah, if we up the screen resolution, sorry, the window resolution, and then we zoom more into the ball. So that is apparently, so that's 10, right? So that's apparently like 1,000 pixels, which seems reasonable considering I've got a 4K screen, so you could probably fit 1, 2. I don't know. Maybe I should take another screenshot. Wait, have I used the alt? Super? Oh yeah, that's right. Yeah, can't quite get it up there. Oh yeah. So I got 4K screen across, isn't it? But yeah, up it's only maybe 1,500. Wait. Yes, but it's 2,160 pixels. That's right. That's right. Yeah. So we just put my finger down for a second. We should be able to fit 4 of these guys in there, kinda. Yeah, I guess. Well, that's the width, and I'm measuring the height. But anyway, it's good. It's looking good. So if we add more of these ellipsoids, it's going to take the max, right? The max of the ones which are on screen. And it doesn't seem to be fudging that. At all. So I can get real close, so I can have ones which are further away, hopefully. Let's up the stakes here. So we've got a full screen here. We've got some really small ones over there, up in the distance. And we've got some like bigger ones down here, and that's saying I need an LOD of 6.8. Now, yeah, maybe we can have more. But yeah, 7 seems pretty reasonable. Because we have at least loaded in is LOD 7. That's the minimum one that we've loaded in, and anything else needs to be sort of streamed in. So I think that's quite reasonable. That we don't have to worry about streaming in for going between all these different level of details and things. Should be pretty cool. So that seems alright. This is only for one material though we're testing out, but that's good. So, you know, but when we get more levels of detail, it'll just work. So we need to now call graphics material cache. Right. When you call update, you pass in the LODs. Okay. Gotcha. So what we're gonna do is when we do that material cache update, which is the function we started writing last time. It's right here. We're gonna, let's put this in its own little thing. So we can get the pointer. And, you know, you might not read it back this frame. No, so like your first frame that you render, you won't read something back. But let's say if you read something back, you get the pointer. And then we'll pass in the array of LODs, right? There's 1,000 of them. And then here in this sort of material cache update is where we're gonna do a few things, right? We can basically, we've got to take this LOD and decide whether or not we want to move it into a higher resolution slot. And do we load that from disk, right? And then like when we sort of, if we decide we want to sort of downscale one, you know, like it's no longer big on the screen and it hasn't been for so many seconds or whatever. So we're gonna choose to move that one down to a lower slot. And we'll probably just do a copy, because what's the point of reading it in from disk again and uploading it when the data is already on GPU, right? So we'll do stuff like that. Awesome. I got myself the real-time rendering book 4th edition is so massive. Oh, interesting. Let's have a look at that. Well, maybe. Trying to not dox myself. Oh, you got this one, right, with the Stormtrooper one, yeah. I heard good things about it. I would bought it myself, though. There's also the, there's also like there's also like a path tracing book online. Oh, PBR online, and it's free. This one is quite good. But I looked at some of the examples and it's straight out of college, you know what I mean? Like OOP everywhere. And it's just like, it's so annoying to look at some of the code examples. But I think some of the theory behind it will be good. And I've just lost. Oh no, the connection's still fine. It just took so long to load that page for some reason. But yeah, apparently this one is good as well. I just haven't had a chance to read it because I don't typically read stuff around my computer. I'll typically have my phone. I haven't bothered looking at it yet. There's plenty of good resources online these days, just gotta know which ones they are. What the crap is this? Let's go back to Stone Rebel. Oh yeah, ray tracing the weekend. Yeah, there's that one. What ones are there? Yeah. There's also the GPU gems. Got some older stuff in there. GPU gems. The NVIDIA ones, they're all online. They're freely available. So they've got 1, 2, and 3. And yeah, lots of chapters and images, everything. You know, that's a good resource. And there's also blogs as well from like people, like folks in the industry that have had blogs going for years. You know, I always feel like I should just like download the internet onto my computer because I feel like stuff just goes missing or I just like can never find it again. You know, people take the websites off or whatever. And it'd just be good to have a local copy of like everything. Or like a video goes missing, you know, like a... Yeah. It's hard to find information about graphics. Right, I'm just going to take a quick little break and then we come back, we'll do all this sort of fancy, like, keeping track of this LOD that we got back from the GPU and sort of how do we decide whether to load a new one in or, you know, downgrade an existing one, you know, stuff like that. So, be right back. Enjoy the tunes. Alright, welcome back everyone. I had so many good reviews for that book, so I just bought it. Yeah, I heard good things about it too. Yeah, maybe I should pick it up and have a gander. I think they've... yeah. Right. So, we've got this thing called a material cache. It's got... for each LOD that's loaded, we start at LOD... you know, it's got so many LODs, but the one that starts at is 7, which is 128 squared textures. Goes up to 4K. So, for each LOD, there is an albedo, texture, emissive strength, meltness, roughness, height, and normal textures. They're 2D texture arrays, and they've got a bunch of slots in them. Each slot is, there's so many layers, right? They can hold up to so many different textures within a single texture, basically. So when you have a material loaded, you might be on layer index 7, and you're on layer index 7 in each of these different texture 2D arrays, okay? So when we sample on the GPU, or when we pass up the concept of material on the GPU, it's just what LOD it is and what layer. And then from that we can sample whatever, because we have to just get the textures and sample from that layer. So now that we have the LODs feeding back from the GPU and getting passed inside this function now, what we can do, so there's this material here, it's been book kept here as a sort of a state. And so I think we want to go over all of the slots, all the materials, check if it's allocated in the material pool, and then update this LOD float value. So we'll start doing that. So for every index in graphics materials capacity, get the, we ask the object pool, see, I wonder, let's have a look. Whereas a get ID from a pointer, yeah, it's kind of a bit crap. I can do that though. I want to, oh, there is an isAllocate index. I kind of want to get a pointer from, so I've done this in the past, isn't it? What have I used it for? No, I've not used it yet. I just can tell if it's, check if it's allocated or not, right? So then we want to add something to the object pool where we can say like get with index basically. So you can do a get with index and it can return a null, right? So an IDX. Get with index. Yeah, so I think what we can do is say there's an isAllocated bit set. if it's not allocated, return null. Then if not, return the pointer. Just like that. Magic. So I got to get the type generated stuff to, it's macros, does the job. It's ugly, which means I won't do it that much. Right, I barely do this sort of stuff because it's ugly. And that's what templates should be. Ugly. So I only really do this for collections. The few that I have. So yeah, we've got this new sort of like get or with index it's called, isn't it? Get with index. Yup. So go back to, right, it's just get with index material. And so passing the material pool, so cache material pool. And we're getting it with index. Okay. So this will get us a graphics material. But it might be null. So if material is null, then we simply just continue. Now, so we can store the LOD in here like so. Well, okay, do I even need to do that? Because I'm going over all the materials here, aren't I? I'm already doing that. Yeah. Interesting. Okay, I didn't need to do that at all, but it was useful to get that, regardless. That function, just leave it in there. So, right, we're gonna, so only when the material is actually loaded do I need to, so if the material has been loaded, then I think it's safe. So when you have a loaded material, I guess we'll do the else if, alright. So if you have a material which is ready, it means that so you set it to this ready state. And that means that you've issued a command to use this material or whatever. But maybe the slot could have been recycled. Yeah, we've got to be careful. Well, the palettes dictate by loading and unloading new. Unload, loaded, ready. And then they unload, right? Yeah, I think it's safe. So we can always assume the LOD that you get given back is definitely for your material that you've loaded. Maybe we could probably it's probably fine just to accept it regardless. Right, so we want to say if so well, what can we say? So I think those material LEDs that we get back from the GPU, we just don't want to accept them, right? So you can imagine like you've got a. So here's the problem, right? Is if this number fluctuates a lot, you're going to just be loading and unloading materials quickly, and you could like move the camera off the screen and move the camera. Sorry, move the camera such that the ellipsoid with that material is off the screen, and then snap back, and then you would basically get a really low resolution material because you've unloaded it by then. So you want to have some kind of mechanism in which that the changes don't apply right away, but yes, you want that sometimes but not all the time. So I think the cases where you want it to be quick, the only case is when something has appeared on screen or is now bigger on screen, right? And yes, only when the thing is bigger on screen. When it's smaller, you want it to slowly go down and down and down and down and down over many frames, and then that will dictate how to change, when to sort of change the quality of the texture basically. So here we want to get the material index, and that will be like, that's this thing here, isn't it? Thank you. Now we'll get the sort of the LOD on GPU. Now what we'd like to say is, if the LOD on GPU is greater than our material LOD, could have just done this, but anyway, if it's greater than material LOD, then I guess we want to keep just apply right away. And then from here on out, we want to have some kind of like slow decay, but I think you probably want the slow decay to happen first. So we've got to work out like a good rate of decay, I guess. So you could say it loses one. Like how many seconds do you want it to lose? One, maybe. Right, 2 seconds. My the baby monitor just run out of battery and he's going to get the charger. Actually, that should be right until my wife gets back. Hopefully. Right. LODF. Yeah. So we want some kind of decay. So we want to say like it's dropping a value of 1 every so many seconds. So we want it to multiply by delta time. Right, so that needs to go in there somewhere. So we want to know like Yeah, I guess this should always be 0 based as well, so that would always keep it above 0. Okay, so my delta time is in in seconds, isn't it? 1 divided by 60. Yeah. So it's hard coded at the moment. 1 divided by 60. So yeah, so we just put it at 1. Yeah. So it's just how many at the kind of rate, isn't it? So I guess we can call it like material LED decay rate. This is a new thing that we'll make. So if we go into that sort of graphics internal, we can just chuck it right about. So the decay rate, so if it was 1, so how much of the LOD per second? So how much LOD should it lose per second, basically? So that we lose 1 every second there. It's quite fast maybe, but let's just try it out. So there we go. And then we can print out the LOD here. So it'll be like material or LOD, we'll put in brackets the material that we're talking about, and then obviously the LOD here. So material index and then material LODF. Okay, so let's just start there basically. So let's do the sync, and we can see the number in the terminal on the left window. So if we here it's about 7.8, so it's nearly 256 pixels tall. Then we move to the left, take it off the camera. Now it's slowly ticking down. Right, you see the number ticking, and it should go down to 0, then stop. There you go. And then we go to the right hand side again, it jumps straight back up to about 7 or 8, yeah, and then it ticks down. Yeah, maybe we want it to be a bit slower. But yeah, we want, you know, I think when it's, yeah, we want to have probably a cutoff point where it ends up being, so we don't want to, oh no, yeah, but when it reaches 0, we'll probably unload it, I think, I don't know. We'll see. So that's alright, that works okay for now. So now we've got to think about the unloading, or the code which decides, like, for this material, how to weigh up the quality. So right now, when it's in this sort of unloaded state, we make it loaded by copying in the new on here. So I guess if it's already in GPU memory, trying to think about like in the future when we want to do streaming as well, you could probably find a new slot where it's going to go, and then say you're going to go there, so you kind of allocated it, if you will, and then you got a process which will, like the async thread will be uploading it, and then on the next frame, and then when it's actually loaded in, you can commit it. Nah, I think, right, okay, nah, let's not do that. Right, so let's say, we take this LOD, we probably want a currently loaded LOD maybe. Oh no, we've already got a layer. Ooh, Yeah, LED float and then LED in, obviously, okay. So these LEDFs, let's look at that. What have we done with it? Okay. LED equal LED. Good, 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 good. So what we want to do is get this LED, so round it up. Is there a clamp anywhere here? We definitely need to be clamping this between. Graphics material, cache LED, material LED. Dim min, min max. Okay. So we take that. And we'll reuse it down here. So I want to say if material LED is, so it's going to be the same thing, right? Load it from disk. If it's, I guess we can always make it load from disk and put it to do in there and say, hey, just do the copy. Yeah. Yeah, it could be an optimization that we do later. Let's just get this one in and working. So maybe we should make another function called like, just does this basically. Kick off the load because it's doing it in a couple of places now. Yeah, well, I don't know what the prototype will be. Just put it here for a sec. Material cache, load material. So you want to have like the actual material. So it'd be the graphics material. Maybe on the material ID as well. And then you would obviously want the LOD that you want to load in. So that's all of this here. Oh. There's a bunch of copies. Currently we don't have a load in from disk bit of code that is going to come in the future. We're going to work on that custom asset file using our custom encoder system. After this is complete, and after we've done a nice procedural texture just to sort of, you know, see what we can do. Yeah, for now I've got a temporary procedural texture in memory, and I just basically copy from that to the slot for now. That's all I'm doing for each PBR material. I need the cache pointer. Alright, it's looking alright. Right, that is all interesting. Yeah, the material slot will need to be updated, that is correct. And then LOD cache is changed bit set, interesting. So I reckon we can do this. Material ID, material itself, then the LOD. So I think we'll need a very similar thing. So when you set this has loaded material, then we'll upload all the materials again. So if one has changed. Then if you change the LODs, it will change the... Oh, it resynchronizes the textures. Yes. Gotcha. Clever stuff. So we need to do that same thing again. To do if the... Yeah, sorry. I need to put to do in here, isn't it? Yeah, like to do load. If the LOD is smaller, is now smaller, then we should be able to just copy the texture rather than loading it from disk again. Yeah, so for now it'd be easier just to do this. I will say the materials have been updated and the LED caches has changed. So resynchronize those textures. And that should be it. So, let's see if that works. I think the shader code is a bit messed, to be honest. Oh, we just use MIP 0 at the moment. Oh crap, that definitely failed. Well, that definitely failed right there, didn't it? I don't know what's going on here. That's recalculating that, isn't it? I don't think that's going to help it. I just removed the shadowed variable. Right. So we're trying to get a resource and it's kind of using an invalid index. That is strange. So it says if the LOD is just invalid. It's weird. Oh crap, the LOD's not been taken away by the base LOD, is it? Right, hang on a minute. So the way you calculate these LODs... Yeah, so... There's an LOD min max. Right, in log 2. So to get it to an LOD value, I need to take away... After we've clamped it, we need to take away the the min value. So we can call, so a more sort of readable name for these would be, rather than log f, it would be log 2, right? Yeah, that'll be more readable, I think. And then to get the log value. Oh, interesting. What is this? Deref. Beautiful. Then to get the log value, it's you round it up, clamp it between the min and max, take the min, and that gets you the log value. Boom. Right, so I don't have any way of knowing if this is higher resolution. It still looks blurry as hell, but it does render. So we need to get some kind of feedback to know like what is going on. Like, so we want to know like so material LOD. Let's just get that printed out just to start with and see if we really are getting updated LODs. So LOD 1, so that's the 256. Then we move it back. It's now LOD 0, which is the 128. Then, right, so we're getting close, just getting the higher and higher LODs, which is great. Cool. Yeah, we've got this sort of seam to fix as well. All right. So it appears it is doing it. So what we can do is we can go to I don't know what one that would be. Yes, definitely doesn't look right, does it? But we should be able to look. Sales LED 4. There you go, that's the 512 one. It's in here. It's been copied there, right? It's been copied here as well. And obviously, we don't clear out the texture cache slots which have not been used, which are not used anymore. So, you know, maybe we could make a shader which clears out a slot and fills it with some sort of invalid texture, so we know, you know, that there's an invalid access going on there or something. That'd be quite handy. But yeah, it's been filled in for this one here as well. I don't know about the 4K one. No, it's not done the 4K one. The 2K one that's done though. So, interesting. Yeah, it would be interesting if we could fit all these slots in with like a shader which would just run at boot, clear out all the, do some really like ugly or basic sort of albedo color or something and just 0 for everything else. And then we could tell whenever there's like an invalid access. You know, typically people use like a, you know, there's like a missing texture that people typically use, right? I think like this is like the valve one maybe. So we just do something like this. Just something that's painfully wrong. Should be quite easy to do that in code. So when we instantiate the texture cache, the material cache here. Oh, wait, let me get that. So load material. Plop that in the header as well. So we'll have another one called like we'll have two functions. So fill invalid. Maybe just do one. Yeah, maybe a lot of cache. They want to fill, and then probably the layer. But if you're doing it from boot, you know, I think you only really want to do it when you've filled in a when you've deallocated something, maybe. Nah, I should do it for all of it. I don't put tons of dispatches in though. So if you put a U32 max in, it'll do all of it. Something like that should be wise. So you can make a new shader. There's nothing material in here, is there, really, other than the surface shade? Oh, it's here when yeah, okay, good. Let's just fill it in here. So you want like all your layers, which means you can do the 8x8. You do at most 1024, isn't it? 8x8. We get 64. We got up to 1024 slices though. Material cache, fill invalid. I wonder what we do for the, I guess we'll just do it once per slice. Or we just go over all the slices in the shader, be right. So you just go for every layer, index, 0, how many layers. So you might have like a base layer. So layer, start index, layer, end index, right? And then, wait, what am I doing with that? So then here we can get all the different textures. That'll be in graphics, internal, shared. At the bottom, all of these guys. For a specific LOD. They're just globally accessible. Although they're the damn sample ones, aren't they, damn it. So they could be passed up in the shader. Yeah, we'll pass them up in the shader. So I want to set all of them basically to 0 except for, so we've done it in the past up here. This will do. So we're not just having like an albedo color. It should be quite easy to make. If we take the, why did I say LED? Albedo. So that color's going to be like, so just do a simple grid. I forgot the little trick you can do to do a grid. There's a neat little trick you can do. Huh. Maybe I can work it out. But then we'll get a color based on that. So emissive will just be a black. Everything's just going to be zeroed other than the albedo. So just look out incredibly out of place. Height will be 0, I guess. And then the normal probably get by with that just being 0 as well. Well, maybe that needs to be norm. But the UV. Yeah, maybe that makes them just a regular normal. Right, scale those dispatch in the right place. Right, this needs to be though a texture 2D array. So we will need a sort of 3D coordinate, which will basically just be uv.x, uv.y, and the layer index. So this has all got to move inside the loop here, like that. Cool, cool, cool. So now I'm just going to work out this albedo thing. So it was going to repeat this sort of like missing texture. Then, you know, it's like a grid, right? So there's a trick you can do to sort of get grid pattern. Just got to work it out. So x, 0, 1. Right, so for the first row, yeah, so for the first row you want x to be, so say x. See, you're taking like a 2 by 2, isn't it? Yes, I think you can do. What do we want to add? Probably a floating point, yeah. So whether or not the cell is on. So I think you could take the ucord dot x and 1. So that'll get you 0, 1. Right. I don't know what's a good image to look at, to be honest. I'll explain this. That one's the best one. Yeah, so if you take the x, it'll be 0, 1, 0, 1, 0, 1, 0, 1. But when you go to the y, it's the other way around. It's 1, 0, 1, 0, 1, 0, 1, 0. So you need to sort of XOR that, right, to toggle it only when the Y is odd. Is that right? I think so. Yeah. Something like that, and then just make that a float, please. There we go. So if we take that result, that V result, and then we can basically like yeah, we can scale the color. So whatever that base color is, so the color that we want, should we steal this purple? Or so we can, I already got magenta. So we can just say like unpack a color magenta multiplied by V. But I guess V could just be actually just, we'll call it is on. And then that should do it. So it'd be black or magenta basically with that code there. Cool. So let's just launch this thing, see what happens. So I do need to make this a thing though. So hang on a minute. So if we find where we've done that sort of test material, still all these things, there is a dims in there. That's probably useful. Yeah, that would be useful. And we need to make them 2D arrays for this one. Crap, I clicked too much there. Array. Okay, and then we also need probably the layer. Did I call it layer star next or layer? Alright. Layer start index, and then layer end index, okay? So I think that's all the parameters that we would like. So all we've got to do now is go ahead and launch this thing. So I want to go over to the CPU side code and graphics and fire that away. So BC equals this thing here. And let's find a good old dispatch line. There we go. Dispatch material cache fill invalid. So we've got to get the dims. So I think the dims are in the, oh, you would think they're in the cache, isn't it? But right, I can get the dims. GPU texture dims, LOD cache, albedo, that'd be good enough. And we just want to fill in all of these little things. So it'd be BC dot. Oh, what's going on here? Albedo equals whatever. So I've got to find where we do this and steal it. Save all that right now. So that'll be based on LED cache. So they're all read write. And now it's got to put in all of the extra things. So there's dims equals dims. there's layer start index. So that's always going to be... Okay, so it's either 0, then all of the layers that the LOD cache has. LOD cache layers capacity. So if you provide some kind of layer index explicitly, we only really want to target a single layer. Right, this should work out quite nice. Layer index and then layer index plus 1. Right, so how many of these did we launch? Well, it's like this one here, right? It's the dims divided around up by 8. And that'll do all the lovely array layers as well, which would be nice. So all we have to do to get this working is... So we do it from boot, and then obviously do it whenever we have decided to remove an existing one. So that'll be... So boot. The issue is I've got to... So after we do a start, we'll do it here, so we'll launch all these guys. So do a for range over, I guess do it after this. So it's the LOD. Material LODs count. And we're going to get the material LED cache. Graphics material LEDs. Okay. Now I just want to call that lovely function that we made, graphics material LED. Sorry, cache fill invalid. To be honest, we had a better name. I don't know. Right, the layer index to U32 max to fill them all in. So that's a boot. And then when we're in the when we are in the update function, we would like to unload. So you would like to say unload material layer index at cache LODs material LOD. Right, so I'll fill in some kind of invalid and then load in the new one. Cool. So now when we run it, we'll get all this sort of... Oh, hang on a minute. We should clearly see if there's any use after free, basically, that sort of thing. That was called coord, wasn't it? Right, it's meant to be a integer there. Whoops. Wait, why is that a UV? Oh crap, I meant to make that coord. Sorry, ucoord. Oh, thank you so much for the raid there, TJ. Welcome. Thank you, guys. How you guys doing? You're just about to see if it works or not. Good timing. And we've got a ball. Seems to be going alright. The ball is being rendered with a horrible procedural texture. How did the stream go? Appreciate it. Yeah. I couldn't be bothered to do another Vim config, so I was like, I'm giving Helix a go. But yeah, what you guys been working on? So we're currently working on a game without an engine, as you can tell from the title. And we're doing this weird sort of like ellipsoid base renderer, and we're just working on the materials part right now. So we're trying to make the spheres, or they're actually ellipsoids, but it's currently a sphere. We're trying to give them more detail. Yeah, here's a big wall of ellipsoids. Just it was testing out performance, but I don't need that at the moment. We're currently just trying to make this ball have better quality. So we're just kind of testing the LOD system, the loading system. We've got it sort of feeding back from the GPU. What is the LOD of the material that we want to load in, and then loading that in from disk. Well, it's not loading it from disk at the moment. It's currently just loading it in from another texture on GPU, but it can be replaced for the disk one soon. That's currently what we're working on. But yeah, hope you guys are having a good day. Feel free to ask any questions if yeah. Okay, there's our missing texture shader coming in here, but it's not quite working. I tried to copy the Valve missing texture, and I was in it in a computer shader, and it's so damn close. But hang on a minute, it's not filling in all my pixels. Why? Right, that needs to be 64,1, and then it'll work. Yeah, so we added some code to filling all of the material cache slots with invalid. With an invalid. So here it is there. Oh yeah. So that is, so we should, okay, so that's marked as invalid. Then that one shouldn't be. Where is it? Ah, here it is. It's in LOD 2. Okay. Then obviously if we go to the next layer, which is a completely different texture, it's invalid again. Look at that. Pretty cool. Maybe not doing it down to 1 pixel is a good idea. We should probably make it a bit thicker. 1 pixel's a bit bad. It's just so. Right. Let's improve that array code. So is on. If we did. So we do like a grid dim. Oh, well, how big is the grid cell dim, right? So we'll say it's, I don't know, 32 pixels enough. Then if we just divide this by grid cell dim, that will give ourselves a super lovely grid pattern. That's just a little bit chunkier. Want some of that chunky in my grid. So let's have a look. That's better, isn't it? Nice chunky grid cells. So if we go to the higher resolution, right, let's go to the other layer where another material could go, and it goes there. Good. So as we move through the ball stream, nice, exactly. There we go. Right. So as we move the camera around, so if we move the camera and it goes off screen, the LOD will slowly tick down and then it will unload. So I'll move to the right now. There we go, unloaded. Loaded in. I did see it flicker off though for a second. That is not very good. It kind of flickers off, then loads again. I reckon it flips between the boundaries of the LODs, isn't it? Yeah. It ends up loading. There's probably a sort of an edge where it's like, yeah, it's just on the boundary right there. then loads back in again, then loads off. It might be to do with the bounding box size or something like that. Oh well. Stuff to iron out. But yeah, it doesn't seem like it's better quality. This is so damn blurry, my eyes. So, why? So I think that's maybe the sampling now. So what's great is that we're filling in all of the invalid slots for where the texture used to be, but it's just when we're sampling it now, it's probably that code is wrong. Yeah, so we're sampling it, it's always sampling from the right location, and we can guarantee that because we're looking at these sort of slots it's going into, and there it is, right, it's in the 2048 squared texture. So now, I don't know, maybe it's just the texture's crap anyway, isn't it? So why don't we change this texture out to something more clearly has resolution, if you will. Yeah. I did something noisy, so it's probably quite blurry. How about let's just do another grid pattern. But this time we'll do a different color, if you will. So magenta's the one with an error. And teal's a good color. I like a good teal. So we could do a teal and black, I guess. So that's albedo. Crap. It's a sort of simplex noise thing. Oh, I didn't do the sRGB conversion. It's so easy to miss that. Right, let's get back to that. sRGB. No. It's already an sRGB. Just unpacked. Right. In that case, I don't need to do sRGB there. Beautiful. Metalness and roughness will be randomized though. Yeah, we'll keep it like that. So let's try this new one out. See how it looks. Rightio, here's our new high quality, top quality sphere texturing. And it's heavily distorted like mad. Right, let's have bigger cell sizes. And the normal's probably all messed up as well. Bigger cell sizes, let's triple that, I guess. Hey, Velibus, how's it going? Sorry. Foulbus. Welcome back, sir. How are you doing? Also have two variables called albedo. Right. Yeah, I used to. Ooh. Is ball made from vertices, or is it one of those 2D planes that always faces you? And you do everything inside of the shader. Oh, interesting. So the answer is no. Basically, it's done entirely in compute. Oh, okay. The answer is actually yes. So I've got two different renderers. I did it entirely in compute. I've got this one which does the visibility buffer approach, where it renders out just a bunch of object IDs for this ellipsoid, and then it will shade them later. So that puts a rectangle around it, and then does a ray-verse ellipsoid for every single pixel. And then if it hits it, it's like, aha, I got a hit. And it writes out the ellipsoid that it hit into a pixel. But I've got a better shader, which I actually wrote first, but I tried this other version out, which does tile binning. So it takes all the screen bounding boxes around the ellipsoids, and it bins them into screen tiles. So the screen tiles are just essentially chunkier pixels. And this, the benefit of this approach is that after you bin them into screen tiles, I sort them front to back at the same time actually. And I can I see like the scene? Oh no, I can't. I don't have a debug texture available with it. But imagine it's like a larger grid, and it's got 16 by 16 pixels. And what it'll do is it will sort them into these screen tiles and sorts them front to back roughly. And then per pixel, it goes over all of the ellipsoids within the screen tile and does a ray trace against those and tries to see which one it hit. And it does some sort of sorting as well with the 4 hits that it gets. And the beautiful thing about this is you can have 4 layers of transparency per pixel. It's quite cool. So I want to go back to using this method because it scales the best up to 4K, whereas the one that puts a bunch of boxes around all the ellipsoids and tries to render those, you get too much overdraw. And it's great for the lower resolutions, but for the higher resolutions, it's not that good. So yeah, I think I might keep both renderers just for that fact that it is good at... Both renderers are good at different things. Right, so we don't really get a seam. Yeah, you can clearly see a seam there. It's oddly dark here. I think that's the normals. Or it's the lighting, but anyway, let's look at this side. Yeah, it's a bit of a weird... maybe the grid pan isn't a good idea, but you're seeing a bunch of sort of odd stretching here around the seam, isn't it? The distortion. Maybe we could do the cube. Because I'm doing a grid pattern, maybe. I wonder what else we could do. I wonder, hey. So it's in that sort of noise thing. I could just do a gradient. Yeah, why not do a gradient? I've got UV, isn't it? UV.x, UV.y, 0, 1. Yeah, I think we'll just try that out. We could multiply it by is on as well. So you basically get a gradient with this. I don't know, maybe it's probably not a good idea. Alright, so now we get to see the borders a bit better. Yeah, this sort of creases. So we're using the octahedral mapping. So it maps. Crying out loud, what's going on here? Octahedral mapping. So it's a way you can map sphere into a flat 2D plane by going from the sphere to the octahedron and then into the texture. So it's quite clever, right? So each kind of quadrant of the sphere maps to, it's kind of just, you remove the roundedness and it's the same as a octahedron, and then, in a sense, and then that gets mapped to some triangle, right? On the, there is some distortion going on, and there's some sort of like edge creases at the edge. So yeah, we've got to figure out why that is and fix that. I remember hearing about it, but also as well, it's that maybe it's the way I've decided to generate the texture, because I've just done it. I've not done it based on the normal. So instead of I take the normal, yeah, let's just do it based on the normal. And these metalness and roughnesses are causing it to be reflective and not reflective, and that's why we're getting this pattern, right, where it's sort of reflective and reflecting the environment. So, and that kind of looks very low resi because I'm doing that silly noise thing. So why don't we just hard code these to like 0 and 1 roughness or something, and then so I'll just make it look a whole lot better. And why don't we take the normal here and use it as the albedo? So where's the normal? I've got to unwrap it, haven't I? n.x, n.y, n.z, and I think we can just use normal equals unpack octahedral layout from a UV. So it unpacks it from that 2D quad, puts it back into the as a surface normal on the sphere. And if we use that to color the albedo, then that should be correct. And we can look at the texture as well in the we can look at the texture in the texture viewer to see what that looks like. So this will give you a smooth normal now? No? Maybe not. Oh yeah, you're getting sort of purples because they're negative values. Interesting. So let's look at the texture for that. Right. I don't know if this is correct or not. Can we look at lower MIP? I can zoom out. Okay. So it's as if like that's going across the X. Wait a minute. Yeah, that's as you go across the X-axis. That's as you go across the Y-axis, right? Because that's red is in the X. X is in the red. Y is in the green. Do any textures up front, or could they be directly created and stored and live and lazy in the browser, or do you need a canvas to create and clip it, then convert it as necessary to do that runtime on demand? So I'm not using any sort of like web technology. So I'm seeing the web browser and canvas, and I'm sort of feeling that from the question. What we are doing is planning on writing a procedural texture system in the editor. So because I'm doing this sort of like sphere rendering, you know, I can create these textures in some external program, but it'd be more interesting if I could just do it with shaders within the game and have hot co-reloading and have a nice little texture viewer. We'll make another sort of bit of UI for this, and ways to sort of like make textures through code with some parameters on the side that we can tweak, and that will change how that texture looks. And then you can output that as a new texture file, like a new set of textures that then get loaded into the game when you need them, basically. So there'll be these sort of, I'm calling them proto materials, where they're essentially a set of sliders and a shader. And then so you can make many different materials from that of different, you know, you can have like a rocky looking one, but then maybe you can sort of scale the rocks up and stuff like that all within the same shader and generate different materials. So I want to be building this sort of procedural texture system such that we can tweak and have a play with materials and make them better on the fly. well, sorry, in the editor basically, and then save them out. Yeah, that's what we're looking at. It was pure JS. Yeah. What made you think that? Hey, the coffee lover, welcome, sir. How are you? So going across the x-axis, going across the y-axis. I think that makes sense, right? Well, it depends on which way you look at it. Maybe I've not got a good function for it. So this one is kind of going across the x-axis there. Oh, okay. Yeah, if you look at this one's a good one. So you got like a... Oh, no, it ain't. Right. Yeah, okay, this one's a good one. So you got blue, green, right? So you can treat that as the x-axis, right? Kinda. But then once that goes onto the other side, oh my days. Yeah, it's difficult. Because we're sampling from it, we're getting all these creases. There's a way to solve it. I just got to do more research into it. But maybe the octahedral layer might not be the best one. We could do a cube map, but then you got 6 faces instead of 1. So, yeah. Oh, so I don't know if this is the right... Like... We could snap it to a axis. That's another approach we could take. So we could say like if n.x is bigger than Hey Lupo, Bagger's ball remotes. Yeah, not doing bad. Just, you know, probably yeah, it's just getting pretty tired at the moment basically. Kind of at the end of the day. But yeah, doing good. We've got this texture streaming thing done, actually, so I'm quite happy about that. Done that today. We're just looking at like this octahedral mapping and seeing like what the crap is going on. I think I've got a little bit wrong, but this is definitely looking more higher quality, and as I zoom out it should stream in the lower quality ones. But yeah, and then I got another, yeah, and then we're not obviously sampling as well in the shader with the correct LOD. Oh, I gotta, sorry, the correct MIP level. I've got to calculate the MIP level correctly. I haven't done that yet. So something to do on the to-do list. So we're getting close until we're finishing the rendering code. Look at that bloom. Oh. And then what I want to do is work on actually making a really cool procedural texture. Like, I was thinking wood's quite a basic one, but that we could probably do like volcanic ground. I'm thinking of like something like this would be pretty fun. Because I can imagine you can make a shader where you can like control how much of a gap there is between the ground, and then also how sort of lava-y is it? What's the lava-iness of the cracks between the ground? And then you can make a texture for that, and then probably say like how bumpy it is, maybe to make it more bumpy. And then you can produce probably a bunch of different volcanic ground-looking things. But yeah, it's just that'd be a bit of fun to play with. See if we can make something like that. It's not really a good picture, is it? Something like that. Oh. That'd be fun. What do you do for work? Oh. No, yeah, I work in the industry, and I work at Media Molecule. I do 3D graphics, and yeah, my job title was engine developer, but I'm on the graphics team, and I'm working on, obviously graphics stuff and engine related stuff. So it's pretty cool. Got a nice team. Really enjoy it. Yeah. So this I just do on the side because, really enjoy this sort of stuff. Enjoy learning and want to increase my skills, but also build some project that hopefully goes somewhere in the future. And share it with people on the internet so they could hopefully take away some bits and bobs from what I'm doing, basically. And I just want to do something really weird, right? We're rendering like spheres and ellipsoids and stuff. Can we make that look good? Basically, there's been a game in the past which I got told about. I was just doing spheres initially. I think it was called is it Excalibur or something like that? I don't know. Ellipsoid graphics game. I think it's called Estatica. Estatica, something like that. This is it. So this was like probably before I was born. Someone rendered they pre-rendered the backgrounds, but the person was rendered in real time, and the other entities. So it's pretty impressive. And it's all made with ellipsoids, I think. Pretty incredible. So yeah, it's possible. It's just whether or not when you put PBR on it, can you make it look good? Is the vertex shader also done with your computer, or is it done with the traditional Vulkan? So it's just a compute shader. I just use compute shaders. I don't use any of the traditional pipeline stuff. So that's why my GPU APIs are very, very simple. It just literally has a few ways to create textures, has ways to copy textures and buffers, and then dispatch compute shaders, and that's it. So yeah, I don't use any of the traditional rasterization pipeline or anything like that. I don't render triangles. So I could probably benefit from using that sometimes, but I've chosen not to use it at all. It makes the API more simple. So yeah, as you see, this is all rendered with ellipsoids and things. There's sort of so many stuffed in there. This is all pre-rastered at the back, from what I understand. There are some blocks here though, so that's obviously not ellipsoid. So they have used some hard edges, but these are all ellipsoids here. So you can cram a bunch of the same stuff on top of each other. It's just, and then maybe you can select a very specific material for a particular piece and put something on it. So there's ways to do things, and maybe to get detail like eyes and stuff, that'll just be a separate thing, like maybe decals or this is very low res, so it's definitely different. But yeah, I think we can make it look good. It'd be fun. I mean, it must be hard coming from work after do this hard stuff, but not really. I just got to make sure I get enough sleep, exercise, don't eat too much crap, keep the energy levels sort of, going at the same level. Don't sort of try and eat too much stuff, which will cause my energy levels to rise higher than crash. And just got to make sure I'm having fun at home on my own projects as much as possible, but obviously there'll be some times where I won't be enjoying a particular part, but that'll always be, you know. But yeah, just try and make it as enjoyable as possible, really, where I can. So, yeah, it's not too hard. Because I have quite the drive to do it, I think. You know. Find it really interesting and a lot of fun. Yeah, the Bulma developers. Yeah, it's good memes. Yeah, so right, in the next stream then, what we're going to be working on is figuring out this octahedral layout thing. We've got like creases and stuff and all this. It's not good. So let's tick off when ellipsoids render, we need to emit the LOD, separate buffer. Well, we didn't really do that in the end. Dispatch a compute shader and yeah, so we ended up going for like when we emit render ellipsoids, you know, put the max LODs into an LDS buffer, calculate the max LOD by taking the atomic max, read that back, that's what we did. And we've done the streaming as well, basically. Where was the streaming? Read back. Yeah, and do the streaming in, basically done, okay? So the only thing that's left to do is calculate the MIP level correctly in the shader, and so we're doing that. And then also work out the what sphere, pick a projection, sphere projection, sphere to quad. Okay, sphere to 2D texture, projection, mapping. So either we've got, we've got the octahedral, spherical, it's not going to be go on, dual polaroid or a cube map. A cube map's going to be a lot of memory though, I want to avoid that. Dual polaroid is the other one, it's 2 textures instead of 6. But it's probably got distortion as well. But yeah, in the meantime, guys, there is a Discord if you want to come and hang out. I am so tired right now. I'm probably going to crash. Hopefully my wife is still up to say hi. But yeah, next stream will be when? Sunday about 5 hours ago on Sunday, but then about 3.5 hours ago on Tuesday and Thursdays. So yeah, let's find someone to raid. There is a Jai person called Patrick. Let's raid the Jai guy. Maybe he's lying to us. Maybe his name isn't Patrick. That'd be the twist. Right. Have a good one, guys. Catch you later. Have a good start to your weekend. I'll see you in a future one. Right. Bye-bye.